Morning, everyone, and welcome. My name is Nathan Heston. I'm joined by my colleague, Daniel Moyer. Good morning, Daniel.
Good morning.
We are going to cover programming Sol-Ark inverters that are paired with Briggs Stratton batteries today. And specifically, we'll mostly be talking about the 6.6 battery that you can see on the screen there, but this programming really is general for Sol-Ark inverters for most batteries. And we'll also be talking about the use of generators with Sol-Ark. And our two-wire signal to start generators, as shown on the screen there, can be paired nicely with a Sol-Ark, and we'll talk about how those can be used to create essentially a hybrid system. But as we get started, let's first note this is a NABCEP certified training. And if you're here for those continuing education credits, please stay through the end. Daniel and I will check the attendance log. We'll have you send us an email to let us know how your name should appear on your certificate, and we'll get those issued tomorrow. Additionally, we are going to be at RE Plus Texas, and our booth there. I think, Daniel, do we get a booth number on here?
Yeah, booth 524. I really like these regional shows a lot. The regional shows are a little more intimate. They're ideal for, people in your area. So we'll definitely be there. Please come on by the booth. If you do get it to RE Plus Texas, tell them we sent you, and we'll make sure that we have a gift for you there.
Yeah, great. I appreciate that, Daniel. And absolutely, we love it when you stop by if you are at these shows and ask questions. Love those challenging questions that come in as well, too. So please do stop by our booth. And if you are there, if you aren't there, we'll let you know the next place we're going to be. And I do believe Daniel's got a training coming up also in May in Madison, Wisconsin. And so if you're in that area, reach out to us and we can get you set up to attend that training event. Just a note here about Briggs & Stratton. If you're not familiar with our brand, we are a 117-year-old company, been around since 1908. We're sold in more than 100 countries. We've got more than 5,000 employees, and we have 5 regional headquarters. So we're known for our engines, specifically those small engines that you may have encountered in a go-kart is a typical one, or a gas station, or sorry, a lawnmower. Generators as well. So we've been doing generators for a long time, standby generators. We've also been doing lithium batteries, and that is a less known fact that Briggs & Stratton is a big player in lithium batteries, both in movable batteries for like rental type equipment, golf carts, lighting, that kind of thing, as well as stationary equipment, which is what you're here to learn about today. So the stationary batteries for residential backup and like commercial backup are what we're going to be talking about. Briggs & Stratton acquired SimpliPHI Power about 3 years ago now. And so we have a full lineup of home backup batteries featuring LFP chemistry, including the stackable 6.6 battery, which is our newest battery offering for the residential market. We have the PHI and the AmpliPHI batteries, which are legacy batteries, which also have the advantage that we can put those in some of our outdoor rated enclosures and integrate heating systems. Additionally, we have a line of high voltage batteries. We can go up to 1200 volts with these battery offerings, and compare with some native 3-phase inverters, such as the Sol-Ark 60K and 30K, as well as the Oztec inverter brands. And so if you're interested in commercial applications, we have those. We also have standby generators for the residential market. The ones you see on the left there are air-cooled generators, running up to the largest air-cooled generator on the market, the 26K Briggs & Stratton. And we have a line of liquid-cooled generators as well, going up to several hundred kilovolts. We also have transfer switches that can offer some load management. And so with the Symphony Choice transfer switch, we can do some smart loads and have loads come on in a way that doesn't overload generators.
One quick comment on the generators, Nathan, is that the liquid cooled generators come in 480 or 208 3-phase. So that's a really nice advantage for the light industrial commercial as well. The air cooled come in 13, 18, 20, 2 and 26K, they are all 240 split phase. Additionally, the 18 and 22 come in what's known as non-emergency use, or they're warranted for off-grid use as long as they're paired with another energy storage system. So that's a really nice advantage. Not everybody warranties their generators for off-grid use like we do.
Great, and we'll show some examples of that here in a few minutes. It's also notable that our batteries, we do make a 24-volt battery still. There aren't a whole lot of manufacturers that are doing that. That's the 24-volt PHI battery produced in Oxnard, California. And then both the PHI and the SimpliPHI and the 6.6 have 48-volt options. Which is a lower voltage option, which offers a little bit less restrictions on installation, etc., for batteries under 60 volts. Daniel, we are pairing with Sol-Ark for an inverter. What are some of the things you like about this pairing?
Well, one reason I really like Sol-Ark is that they were the first to market with a hybrid inverter where they put all the parts and pieces, the charge controller, the inverter, the rapid shutdown, all of those parts and pieces in one inverter. Additionally, and we're going to get into it, I know we are, Nathan, they pair really well with generators. We can not only bring the generator in on the grid port, but we can also bring the generator in on the gen port as well. I really liked their app, the commissioning. I would also say that they have great tech support as well and engineering support as well. So great team, and I look forward to other inverter pairings as well as they come onto the market.
Thank you. So we did put together some packages. These are mostly packages to guide homeowners in the expected amount of backup time they can get when paired with our 6.6 batteries. Note the different size inverters that are used there at the top. Probably our most commonly used package is the one on the far right side. And that's shown with a 20 kilowatt hour battery stack there, so three 6.6 batteries. And a 15K Sol-Ark. And one of the advantages of that 15K Sol-Ark is it has 200 amps of pass-through, meaning it can allow 200 amps of continuous 240 volt AC current to run from the grid connection through to the loads. Now, that doesn't mean the inverter itself is capable of supplying 200 amps at 240. That inverter is capable of surging to 100 amps, but it can provide 50 amps of continuous power. And then the other two inverters that are shown there are for partial home backup systems. The 8K, typically we'll see customers use that for smaller selective backup. So we're calling that essential power. And you're looking at backing up maybe 50% of the loads in the house. You're going to back up the refrigerator, you're going to back up the lighting, the communication system, but you might leave off the electric water heater, the dryer, the electric dryer, those kind of things. And with the 12K, you can hit maybe 75% of the loads in the house, but you're still going to be limited on overall power. And one of the limitations on both the 8K and the 12K is 62.5 amps of pass-through power. So it's really hard to back up a whole home, at least a grid-tied home with these systems. One nice thing about the 12K and the 15K is you can parallel them. So if you need more overall power, you're able to parallel up to 12 of those inverters. There are a lot of things I like about Sol-Ark. The fact that they've got that big 200 amps of pass through. I know other companies are coming out with that as well. But the programming is fairly easy in the Sol-Ark, and a lot of things are built into that. We can even help you program your inverter remotely. So if you call our tech support team and you're having trouble, if you share your site with us and give us administrative privileges on the site, we can actually do the programming for you remotely over the phone. So just as we get started here, we're not going to spend a lot of time on this. We figure most of you that are on this call already know what an energy storage system is. But essentially, a battery energy storage system allows you to store energy from various sources. It could be from the grid, it could be from solar, it could be from a generator, and then discharge that battery to convert that DC that's stored in the battery back into AC electricity that the home can use. So that's essentially what an inverter does. The batteries themselves are DC batteries. They're 48 volt nominal. The inverter has the ability to manage different power sources. So we could bring in solar, we could bring in a generator, and we could start that generator at specific times. Maybe we only want to use that generator when the battery gets low, right? So there are ways that we can manage power with the inverter, and we're going to be talking about those. As an example of the inside of an inverter, the electrical connections, we're showing a Sol-Ark 15K. You've got dual battery inputs on the left side of the inverter. And you've got DC breakers to control that, to be able to shut off essentially your battery power if you need to do servicing. And overcurrent protection there at 200 amps. We additionally have the ability to control through the accessories bars things like, as Daniel mentioned, rapid shutdown, automatic generator start. There are CT inputs there, so you can monitor power coming in from the grid. You can even monitor power coming in from the grid and use time of use settings to completely offset that, essentially limiting power by discharging the batteries. On the right side of the screen are 3 different AC connections. So you've got a generator input or maybe a smart load output, or you could bring in AC coupled solar through that generator port. So that's the one on the left. The one in the middle is the loads output. That's rated at 200 amps. And then we've got a grid input on the right side rated at 200 amps. We've got neutral and grounding bars on the bottom there.
You know, Nathan, something we don't always show is the outside of a Sol-Ark. You know, a couple features is the disconnect for the PV. That's another part that we don't necessarily need, and then it also still has a screen as well. We
Yeah,
do
that's a
have,
nice point, Daniel. I mean, there is a PV disconnect. So for DC solar coming in, there is a switch on the left side there. It's one more thing that Sol-Ark has built in to kind of save the installer having to install an extra component.
we do have a question, Nathan.
Go ahead.
Michael's asking, I bought the Sol-Ark because I thought the last training represented the inverter could handle 200 amps on or off grid. Is it 50 amps and 150 amps has to come from a fuel powered generator? So I believe Michael, maybe clarify, but I believe he's asking, you know, if it's off grid, Nathan, how much can it provide? But if we tie in a generator, how much can we provide?
Yeah, so excellent question. So the question, I believe, as you said, is, hey, if we're using this off grid, do we have the ability to pull 200 amps through the inverter? And I think so the answer to that question, if I've phrased it correctly, is that as long as you connect the generator to the grid input, then you should be able to pull 200 amps of continuous power from your generator. Now, of course, you'll need a generator rated at 48 kilowatts to do that, right? But you do have the ability to pull that much power through the grid port. If you hook it up to the generator port, you're going to be limited to 80 amps of continuous power pulled from the generator and sent to loads. And if you're looking at the output of the inverter from battery only, you're limited to 12 kilowatts, which is 50 amps of continuous power. So hopefully that answers your question. If not, please clarify. Daniel, we are showing here just a quick single line diagram of, a Sol-Ark 8K. This is to show an example of a partial home backup. And we're showing, 60 amps of pass through there. There's a notable difference here in that you have 2 separate load panels, right? You have your main panel, and then you have your essential loads panel. And one of the things you have often said about, the Sol-Arks is it's nice that they have PCS control. They're rated as a power control system. And so that you don't necessarily have to upgrade your main service panel. You can just limit your output. If your buses are limited to 100 amps, you could limit your output to 20 amps back to the grid. Or if it's a 200 amp main panel, you could limit it to 40 to cover that 120% rule. Additionally, you have the ability to pass through 62.5 amps, and so we're showing a 60 amp breaker feeding that Sol-Ark, and you have pass through of 60 amps. But to the question we just had, essentially you are limited with an 8 kilowatt inverter to about 8 kilowatts of power coming from the batteries. Now solar can supplement. In the case of a 15K, you're limited to 12 kilowatts of power coming from the battery, but solar can add another 3 kilowatts going to load to give you 15K. And that's this example here. The notable example here is that, hey, that Sol-Ark inverter now, all of the power from the utility is passing through the inverter, and that's passing through to the main load. So that's the example of 200 amps. Now, if we're off grid, instead of having the utility coming in through with that 200 amps of pass through, you potentially could have a generator coming in 200 amps of pass through. So Notice that just one load center in this example, and this is what we're referring to as whole home backup. Now, that doesn't mean that the inverter has enough power to power a big 4-ton AC and back that up for a long time, right? That you are limited to the amount of power the inverter and the batteries are capable of supplying. And if you have a smaller battery stack, right, a three stack of our batteries is capable of delivering that full 12 kilowatts of power. But if you have a smaller stack of batteries, the batteries themselves might limit your output. So those are things to keep in mind. Again, this is a talk on programming and not a talk on sizing systems, etc. But if you're interested in those topics, please do check our upcoming trainings. So just to familiarize ourselves as we go through, we're showing an example here where we have AC coupled solar coming in through the gen port. So that's one wiring example that we're going to be talking about how to program for. Here's an example where we're bringing a generator in through that gen port. So that generator port is limited to 19 kilowatts of continuous power, that's 80 amps. Here's an example in which we've got a generator or the grid coming in on the utility port for the inverter. In this case, we could have a generator bigger than 19 kilowatts, bigger than 80 amps of continuous power. So if we're using our 26K, you could get that full 112 amps. It's still going to be controlled by two-wire start, and you'll still only start up that generator once the batteries get low, as long as you program it correctly. And one of the advantages of this setup is you leave that generator port open, perhaps for AC coupled solar, or perhaps for a smart panel, which is what I like to use it for.
Nathan, we do have another question.
Great.
Michael responded. He said, yes, that's the answer to my question, but he has a follow-up question. Please let me know when or if a system can handle 200 amps from the DC batteries, parentheses solar. So go ahead, and anybody who's watching, please put your questions in the Q&A. Yes. We'd love to have them. So go ahead. Can the system handle 200 amps from the DC batteries or solar?
To clarify, we are speaking about AC amperage's output right now, or at least I am. So I wanted to clarify. So the Sol-Ark can absolutely handle 250 amps of DC current coming from the batteries, but that's not, I think, what he's asking. The output of a Sol-Ark on the AC side is going to be limited to 50 amps of continuous output power. So if you need 200 amps of continuous output power, you would need to parallel 4 Sol-Ark 15Ks to do that. If you need just to surge to 200 amps of output power from the batteries, you could do that with 2 Sol-Arks, and they could provide 100 amps of continuous output power, but 200 amps of surge. So you can parallel inverters to get there, but a single Sol-Ark with a single stack of batteries, like is shown in the upper right-hand part of the screen, you're going to be limited to 50 amps of continuous output power AC for a single inverter. So
a follow-up question. Can you have a generator on both the gen and the grid ports? 2 generators. I don't believe so.
I guess technically you could. One could be serving as your utility connection. The other could be serving as your generator, but you would only be able to use one set of 2-wire starts. Right. And so if you had a manual start generator that on your grid port that represented your grid, I guess, for an off-grid system, you could do that. And then you could have an auto start generator. I'm not sure why you would want to do that. But I do think it's possible. Just your 2-wire signal to start is going to be controlled by which port you want to have an automatic start generator on. Just quick wiring example, just showing you how easy it is. So one of the nice things about that stackable 6.6 battery you can see on the screen there is that all of those communications wires between the battery modules, the 3 battery modules that you see, are done with our rapid stack connector. And so you really are just left with home runs. So if you choose to use the gateway, the Briggs Stratton gateway, where you get battery level monitoring, then you would have just one communications cable, that white one in the bottom right-hand side of the screen, going out to it. And then that black cable will run through a dongle to get our CAN high and low pins correct for the Sol-Ark. And that's it. Your 2 comms connections, and then you have that battery connection coming, the DC battery connection coming off of those two cables. So the home runs on the battery, and then just two comms cables. In fact, if you're not using the Energy Track gateway, you would just have a single communication cable running to the Sol-Ark. So pretty easy overall wiring here. If you had multiple battery stacks, you would want to have a combiner to combine those battery power outputs. If you just had two stacks, you would have you could be able to use the Sol-Ark dual inputs as a combiner. But three or more
Nathan,
stacks, you would want a
yeah,
combiner. Daniel.
yeah. Sorry to interrupt. Nathan, no, I really do want to just emphasize though the Energy Track gateway, right, provides a lot of granular detail, a lot of extra insight, cell temperatures as well. So it's a great product. But Nathan, if people decide not to use Energy Track, do they need to use a terminator plug?
Yeah, so there is a terminating resistor, and that you'll see that in the integration guide, which talks about how to integrate these pieces of equipment together. And so you never want to have an open CAN port in the CAN bus chain, right? And so a terminating resistor would go in on the left side of the connection where it's showing to gateway if you decided not to use that. So good question. Daniel, this is one of our favorite topics when we have installers out there. Actually, this just happened yesterday. I had somebody call in yesterday. We got that exclamation point on that Sol-Ark screen underneath the battery. And what that means is communications with the battery is not working properly. I had them swap cables. It was a bad cable, right? So there's a cable tester there on the screen. It's essentially a $30 item. Make sure to take those with you when you're wiring your comms up. Let's talk about programming. So we're looking at a Sol-Ark screen here. There's a training wall there in front of you to represent kind of an example of 200 amps of service coming in, and the load center is in the bottom right. But if we look at that Sol-Ark that's there, we need to get this thing programmed. And what we need to do is make sure it can communicate with the batteries. And we're going to talk about how to do that. And we're going to talk about how to do that in different scenarios. So to start off, the screen of the Sol-Ark, those buttons below it can be used. So it is a touch screen, and those buttons below it can be used to set values. And so if you touch the settings gear in the upper right-hand corner, we will get to a setup screen. And you see basic setup, system alarms, battery setup, a limiter grid setup on a Sol-Ark 15K. And to make sure that it can communicate with the batteries, the very first thing we need to do is get that Sol-Ark powered on and tell it that it has BMS communicating lithium batteries attached to it. So in the bottom right-hand portion of the screen, you can see that setting highlighted. To get there, you go to Battery Setup. Under the Battery tab, put a checkbox in BMS lithium battery, and then click OK. OK on a Sol-Ark is the save feature. So until you click OK, nothing is saved. So once you've clicked OK there, then what that's going to do is tell the inverter to try to communicate over the CAN bus channel. Once that happens, we'll now have a screen which should show the battery capacity. So what's shown on the screen there, 398 amp hours, is what you should see with a stack of three 6.6s. The maximum charge and discharge values that are shown there are the default values on the Sol-Ark screen. Those are not the values that you might necessarily want. And so we're going to talk about how to program those here on the next screen.
Nathan, we do have another question.
Great.
Is there any way to view the battery cell temperature in degrees Fahrenheit instead of degrees Celsius on the Energy Track app? And Nathan, that just reminded me, I was looking at my daughter's homework. I was excited to see her doing measurement practice with rulers in centimeters. So I know it's been a long time coming for us here in America. But can we view them in Fahrenheit, or is that
Yeah,
something
so there
that's
is
coming?
a settings in Energy Track. So if you go into the site settings, you have an option to choose whether you're looking at Celsius or Fahrenheit. And so yes, that's a good question. If you need help with that, go ahead and contact us afterwards, and Daniel and I will walk you through that. So great question. Okay, so let's first discuss max charge and discharge. Daniel, there are, on the screen there, I can see a tab for charge and a tab for discharge. What's the difference between the settings for max charge and discharge on this screen versus the next?
Well, these are global settings, so that can be from any power source, solar, grid generator.
Okay, good. Yeah, so if I put 100 amps of charge in here, it's a global setting, and it means if we select, 50 amps from the generator, but I also have 60 amps that could potentially be coming from my solar, right? It's going to limit that overall charge rate to 100 amps. So it won't use any more than 100 amps of DC charging amperage to charge those batteries. So the settings on this screen are the global values, meaning solar plus any other source, like solar plus grid or solar plus generator, as Daniel said. Same on the discharge, right? If I'm discharging my batteries here, it's a global overall limit. So let's talk about what these limits should be for our battery stacks. So batteries have a power limitation, a continuous power limitation on them. They can surge, but that power is limited to safe values. On the charge side for these 6.6 batteries, it's a C/2 rate. And what that does is prevents the batteries from getting too hot if we're charging them continuously, right? And on the discharge side, it's a little bit more complicated because the controller, it's actually a 1C discharge rate, but the controller can influence that. And so these are 130 amp hour batteries. They actually are typically a little bit larger overall capacity than that, but that's your minimum overall current that the battery is rated to, 130 amp hours. So the discharge for a single battery would be 130 amps. For two batteries, 208 amps. For three batteries, it would be 273 amps. But note that the Sol-Ark is going to actually limit your output current at 275. So you won't be able to go above that for a single Sol-Ark. It's also important to keep in mind that these batteries are actually going to be operating at about 50 volts. And if they're operating at 50 volts, your real amperage limit is going to come from the power. 12 kilowatts of power is only going to pull 250 amps max. So a single stack of 3 batteries has the capability of powering a Sol-Ark 15K completely, right? Meaning that full power output. The maximum charge rate at C/2 for 398 amp hours, you essentially divide that in 2, and you'd get 195. I believe it's closer to 198 amps, something like that.
Nathan, we do have another question. Thank you, everyone. Keep them coming. Kevin's asking, can I program the inverter to charge the battery at night with 5 cents kilowatt hour grid electricity? That's pretty cheap electricity. And discharge during the peak time, say from 3 to 7 p.m., to eliminate peak demand charges?
You absolutely can, and we're going to get to that. Daniel and I were talking about that right before. I want to make sure I get to those slides. So I think I might speed up a little bit here. So we can do that, and we can do that through the time of use settings. I also will comment 5 cents electricity is great. I'm excited because I changed my electricity plan here in California, and I get 26 cents at nighttime. It's over 50 cents during the daytime. So yes, you absolutely can do that. So let's look at the battery charge menu. So notice on the setup, we've gone to the next tab over. That's the charge. Here is where we can independently set charging from AC sources. The charging from power coming from the generator port. I'm just going to highlight here with my mouse. Hopefully you can see that. On the generator charge side of things, that's the generator port. So if I have a generator hooked up to the generator port, this would control my overall charge rate from the generator. Daniel, AC or DC amperage is being displayed there?
DC.
Yes, this is from the perspective of the battery, and the battery is DC. So when we say 60 amps of DC charging, that's 60 amps at 50 volts. That's only about 3,000 watts. Right? And when we say 100 amps from the grid port here, we're talking about 100 amps DC at approximately 50 volts. So it's about 5,000 watts there. So keep those in mind. These are DC amperages. I got that question again this morning. So that call came in about that. Are we talking about, are these AC or DC? And these are DC amperages. This is from the perspective of the battery. What's the start percentage there, Daniel, mean? So if I've got the generator box checked and I have a generator on the gen port, what's this 40% do for me?
That's the percent state of charge of the battery that the generator would start.
Yes, that will initiate a charge cycle. So if you're running off the battery because the grid maybe has gone down, it'll discharge the battery until the battery reaches 40%. Once it gets below 40%, it would start up the generator, and it would charge at it would charge the batteries at 60 amps DC, right? And it would also cover the loads in the house. On the other side of things, if I am allowing charge by having this box checked on the grid side of things, then once I'm below 50%, it would initiate a charge cycle if the grid is available, right? So it would only use this generator charge cycle if the grid is unavailable. So keep that in mind. Now, Daniel, there's a Gen Force box down here. There's also a generator exercise cycle. What have we done here with the hours of the generator exercise cycle?
Well, keep in mind a lot of the generators, including our Briggs & Stratton Power Protect line of generators, have the exercise functionality built into them. So what you're seeing here is the Sol-Ark can exercise the generator for you, but by setting all those values to 0 minutes, 0 hours, what you'll do is rely on the generator to do its exercise functionality. You could theoretically operate it here. The Gen Force, you click that and then hit OK. Remember, in Sol-Ark, hitting OK is kind of the save button. That would force the generator to start up so you can test it as well. Nathan, let me ask you, the value 40 and 50%, if this was your home, would those be the values that you would put in there?
No, typically I would use values a bit lower. I would allow my batteries to discharge a little bit more, especially if I have the security of knowing that I've got a generator, right? And if I also had solar, I would absolutely want to charge down to about 20% or so. I'd like to get through the night until the solar can come out again. Once we do initiate a generator charge cycle, it will finish that cycle, bringing that battery up to a 95% state of charge. Now, we can use time of use to limit that so that we're not charging with a generator when we don't want to. And we'll talk about that. One comment about we only really have to set the hour time of the time here to 0 in order to prevent generator exercise cycle from taking place. Also note that the float, absorb, and equalization are all set to the same values here. The communicating battery will set this automatically itself. If we're not using a communicating battery, these values would be different values. The float, we would use 54 volts. The absorption, we would use 56. And equalization, we would use 56, but 0 hours of time to disable equalization. That's a lead acid feature. On the discharge side, on the right side of the screen, we're looking at how low the inverter will allow the battery to discharge before it takes an action. So the action would be once the battery is discharging, maybe the grid is down, or maybe you don't even have grid, the battery is discharging, we get below 20%, the low battery is just going to send an alarm to your phone or through the app, right? Or it'll also initiate a beep cycle in the inverter, say, hey, the battery's getting low, right? That way you know, hey, I've only got about 10% battery life left. The 10% value here at shutdown, right, would be our end. That's what the shutdown here is going to shut the loads off from the inverter, right? And so if your battery gets that low and you don't have any charging source that's capable of providing power, it'll actually shut the loads off. It'll shut the loads off until either grid comes back or solar comes out. And if there is no grid and we're coming back with solar, it's going to allow those batteries to charge all the way up to the restart value here. That's that 50% before turning loads back on. So you could set that a little bit lower. That gives the batteries a chance to get up to speed and solar to get stronger before it turns loads back on.
Nathan, I had a question. So you mentioned that the float, absorb, equalize are automatically populated by the battery BMS. I've heard that sometimes it's good practice to not connect to the battery comms, program those settings kind of to the default, and then if ever closed loop comms are lost in the future, that the Sol-Ark would kind of default back to some of those settings appropriate for the battery. Is that a good idea?
No, that's a great idea. Really, that's best practice, Daniel, right? So what we want to do is make sure that that battery is safe in the event of a loss of comms. And the best practice there really would be to come in, program the float at 54, the absorb at 56, the equalization at 56, and then the 0 hours on the screen before you set up the comms. And that way, if we do ever lose communications, those safer values are going to be in there. The default values of the Sol-Ark actually come with lead acid values. I think it's a 42 volt uh, shutdown value. So these are things that we have to pay attention to, and we'd like to absolutely have the right values for float, absorb, and equalization, as well as the shutdown values in the event of loss of communications. Technically, for systems that are stationary, there shouldn't be much that happens to trigger that, but it's always best practice to do that. Once we've told the inverter that we've got a communicating battery, there's going to be an extra setup a button that appears on that main settings menu, and that's lithium battery info. This is information that's communicated directly from the batteries. So what you should see when a battery has not yet initiated a charge cycle is you should see that it's requesting 56.8 volts, but no matter how many batteries you have connected, it's actually just going to show you it's requesting 65 amps of charging. And that's to ensure safety of the battery. So if I had a stack of 6 batteries, it's going to make sure those batteries are accepting charge before increasing that charge limit. For a stack of 3 batteries, after the charging has initiated, you'll see that charge current limit automatically move up to let you know all 3 batteries are accepting charge. So don't be alarmed if you see a charge current limit that doesn't match what you think it should be. As soon as a charge cycle initiates, the battery will automatically adjust that charge rate. So we're going to jump into programming outputs now. So we're going to talk about using the generator port as a load output. You might want to do this if you have a load that you don't necessarily want to back up. So you've got a load such as a hot water heater that, if you lose electricity, that hot water heater should stay warm for a while, and you don't necessarily want to be using battery power to keep that water topped off. You don't want to keep a pool pump on, right? You might not want to keep the spa on. You might not want to be charging your car, which might have 100 kilowatt hour battery in it, off your 20 kilowatt hour home backup, right? So you can have those car chargers, the air conditioner, the spa, the pool pump shut off automatically if you wire those into a sub panel. And so this is one of my favorite uses of that generator port on the inverter, is using it as a smart load panel. So what we can do here by putting those loads on a smart load output panel, we've got 80 amps of continuous power that could pass through to that panel. That's the 19 kilowatts of pass through on the gen port. But what we do is we come into the battery setup and we would go to smart load. And under the smart load tab, we could tell the inverter, use the generator input as a load output by checking this box. And as long as the grid is present, we could always keep those loads powered. So we check this box that says on grid, always on. It'll keep that sub panel always energized as long as grid power is there, or something coming from grid power, like maybe a generator for an off-grid system. And then the next values that we can see is we can turn off the smart load output if the battery drops below 80%. You can set that to whatever you want it to be. You might want to keep your car charger on until your home battery is discharged to 60%. So you could set this at 60%. The value for load back on is if we've actually hit that low value and the load's output is turned off for smart loads, we're going to wait until those batteries charge back up above 90% to turn it back on. That way we don't get fluctuations of on, off, as loads and power is flowing. But essentially, this is a nice use and very easy to program a smart load output here into the Sol-Ark. Here's another example where we're going to show you here how to program in for AC coupled solar. So we're showing an example that also includes a generator here with a transfer switch. Now that's only one example. If the grid goes down in this scenario, right, what we would have is we would have the batteries, and if they're solar covering the loads, right, until the battery power gets low. If the battery power gets below the threshold that we set earlier for generator charging, right, then that generator would get a 2-wire signal to start. It would start up, the transfer switch would switch over, and now I'd have flow of power out of the generator into the batteries and into the loads for the house. What's this, Daniel, and why might I want something like this?
Well, that's a lockout module from our SimpliPHI choice line of transfer switches. What that will do is turn off the AC coupled solar or open up a circuit that the AC solar cannot run while the generator is running. One thing I also want to mention, Nathan, is you notice in your diagram here that you don't have a disconnect. That's because inside of our transfer switches, those are service rated disconnects inside of that transfer switch. So as long as it's inside of the meter, you can use that and don't need a separate disconnect.
That's a great point, Daniel. Here's an example of an AC coupled system that does not have a generator attached. Maybe a slightly simpler example. Commonly, we see these solar edge grid tied inverters that don't have the ability to add batteries, right? Or we might also see an N-phase grid tied system on the roof, as was shown in the previous example with microinverters. If you do want to have backup and you have a system like that, we can do what we call a retrofit. And so here we're looking at an example where this power coming down from your solar goes into these grid-tied inverters. And then we've got the output of these grid-tied inverters at 240 volts AC passing into the Sol-Ark inverter. The Sol-Ark inverter is using that power to power the loads in the house and charge up the batteries. In a grid down event, if we did not have the batteries, this system would provide no backup, right? The original system. But as long as we've integrated the Sol-Ark inverter with the batteries, the Sol-Ark inverter can be grid forming, and it can, from the battery power, cover the loads. It can also keep this AC coupled solar alive. So AC coupled solar, with a grid tied system, doesn't normally provide backup, but we can allow it to provide backup with a grid forming inverter like the Sol-Ark 15K. So here's a wiring diagram for that. Now we're going to use the generator port as an AC input for AC coupled solar. To do the settings here, we're going to want to make sure we tell the inverter, hey, go to battery setup, go to the smart load port and tell the inverter, hey, the generator port or the smart load port is now going to be used for AC coupled input to the generator port. And if the grid's on, you'll probably already have an interconnection agreement. So if the grid's on, keep that solar alive, right? You do have to enable grid cell if you're going to use AC, you're going to allow AC coupled solar. So you have to have that grid cell box checked. And now notice that the percentage values here have switched. Why is that, Daniel? Why do we want to have the battery shut off at a high percentage like 90%?
Well, we don't want to overcharge the battery using our AC coupled solar.
Yeah, and AC coupled solar, I mean, its job is to pump out as much electricity as it can, and essentially, it's kind of dumb, right? There's not a whole lot to an AC coupled system because it's not designed for backup, right? But with a Sol-Ark, the Sol-Ark is going to be able to turn that AC coupled solar off to prevent overcharging that battery, and we do that by putting this setting here. The 80% threshold is like before. We don't want the AC coupled solar turning on and off right at 90%. So we have a slight discrepancy there. And it says, well, let the batteries discharge until they hit 80%. And once they hit 80%, turn that AC coupled solar back on and top them off again. We're going to get to these time of use settings here in a minute. That's where we can control when we charge the batteries and by how much power we charge the batteries. So we'll come to that in a second. But first, let's talk about programming a generator on the generator port.
We do have a couple of questions,
Here's an example
Nathan,
of an off-grid installation. We would actually have the generator here on the grid port. And here's also, you can see in that picture, there are two Sol-Arks that are parallel there. And we've got our batteries connected. If we are putting the generator on the gen port for a grid-tied system, so you've got utility coming through the grid port, you've got a generator coming in through the gen port, you're going to be limited to 19.2 kilowatts of continuous generator power. It's okay to put a bigger generator on this port, but you do want to have a breaker sized at 80 amps of continuous power. Right, so you'll want to downsize that breaker if you're putting a bigger generator on there to make sure you're not pulling more than 80 amps of continuous power. You can also do the settings in the Sol-Ark to limit how much overall power you're pulling through the gen port. So we'll talk about that. You also want to make sure you wire that two-wire signal to start if you have an automatically starting generator. On our generators, that's pins 4 and 5 on our control boards. And that's a normally open dry contactor. So in the generator, in a Briggs & Stratton generator, this is the sequence that you would use, including the password, in order to disable auto main sensing and enable two-wire signal to start. So this keeps the generator from monitoring and starting up as soon as the grid goes down, right? It allows the inverter to control the start-stop through two-wire. The sequence of setting up the battery charging off the generator there are a couple things to keep in mind, right? So we're only going to charge off the generator when it's on the gen port if the grid is down, right? If the grid is there, we'll charge off the grid first. So as we mentioned before, this amperage for pulling from the generator is DC amperage, right? That's the batteries, that's the amperage going into the batteries during charge. Daniel, what two things does a generator power when that generator is started up by that Sol-Ark?
Not only does it charge the batteries, but also takes over the loads.
Yeah, so it's powering the battery charging system as well as powering the loads of that are connected to the inverter. And so keep that in mind. If you've got, maybe you have one of our 13K generators, you don't want to try to charge your batteries at 12 kilowatts because that would only leave 1 kilowatt of power left over to cover the loads in the house. And so if you do have a 13K generator, one of the things you'll want to do is come over here to the basic setup tab. Now this is under basic setup and then advanced, and you can limit the generator power. And what this will do is it will reduce the charging rate so that you don't overload your generator. So if I set it at 13,000 watts, then if my loads of my house go up to 8 kilowatts, it will reduce the charging rate on the battery down to 5 kilowatts. So we're not overloading the generator. And you can set this value lower as well. And typically with generators, you might want to set that a little below the maximum output of your generator, especially if you're up at elevation where you have to derate your generator output power, etc. So once the batteries get low enough to call for a generator to start up, the inverter is going to send a two-wire signal to start. Notice it only does this when the grid is down. So notice that the screen will display a yellow signal for grid here. This means that the grid has been disqualified, most likely because the grid's not there, but possibly because the grid is out of range. So if the grid has been disqualified, it will send a signal when the batteries get low to start up the generator. And once it starts up the generator, the grid icon will change into a generator icon, and you'll start to see the flow of power. Now, there is a qualification period. It's settable. You can set how long you delay before you use that power. I think by default, it's 60 seconds, but I'm not certain of that. It might be 100 seconds by default. And now you can see the flow of power out of the generator. I still have solar coming at the same time, right? This is DC solar coming at the same time. And those two things are combining to cover the loads and as well to charge the batteries. If we're going to program a generator on the grid port, such as for an off-grid system, maybe as the one that was being asked about at the beginning of the talk, or because we've got a transfer switch because we want to bring in maybe a big generator like our 26K, and I want to have access to that, that full 112 amps of output. Well, I'd be limited to 80 amps in the gen port. So if I use a transfer switch, I can bring the generator in through the grid port. Now, you might also have installations where there's already a generator on the house and there's already an automatic transfer switch. So you can utilize this, and you can still utilize the two-wire signal to start, right? So we don't have to have auto main sensing enabled on the generator. So we can still use a two-wire signal to start. And what's going to happen in a grid down situation is that the batteries would cover loads first. So the battery output is going to support the loads until the batteries get low enough that it starts up the generator and causes the transfer switch to kick over to generator and uses the generator to charge the batteries back up. So if we additionally have AC coupled solar on that generator port, there's going to be some additional considerations, and you can see that lockout module shown here. We still have the generator on the gen port, so I want you to have these in mind as we go through the settings that we're going to enable here. All right, so first, for a generator on the grid port, the first thing we have to do is under grid parameters, just let it know, hey, there's a generator connected to the grid input, right? This priority setting should always be battery first, and the zero output power is kind of a setting for the tolerance of power that can flow back and forth between the grid. The GC controller settings, again, as before, we're enabling two-wire signal to start. And disabling auto main sensing. Now, notice that I'm using the grid charge column for my settings for the generator. So what this is whenever the grid is down and the battery gets below 50%, this setting could be changed. I mean, you can customize the setting, but whenever it gets below 50%, it will send a two-wire signal to start to the generator, which is connected to the grid port, right? Keep in mind that this percentage here is for a device connected to the grid port, and this amperage here is in amps DC. So it'll pull this much amperage DC from that grid port from the generator once it's been started in a grid down situation. So hopefully that's all clear. You can always test your two-wire signal to start by clicking that Gen Force and clicking OK. All right, let's jump to that question. I know we're about down to 10 minutes left. So let's jump to that question about, can I use my inverter settings to charge when my electricity is cheap? 5 cents. Darn, I'm jealous. All right, so 5 cents at night, we want to charge when that electricity is cheap. How do we do it? Well, we can do that by programming the inverter's limiter. And the limiter allows us to control how much power flows to and from batteries during different times. So there are a couple of things that we can do with the limiter. We can do something called grid cell. And grid cell is exactly what you would think. It would be how much power you're going to allow the inverter to sell back to the grid. It'll use the CT sensors to monitor how much power is going backwards to the grid or going up to the grid from the home. And that'll limit both excess solar power, and if you enable selling to the grid through the time of use, battery power. So that's your overall limit. You can increase this value if you've got more excess solar, and you can limit that value. Limited power to home is the ability of the inverter to limit how much power you're pulling from the grid at any instant in time. So if I set limited power to home, there's a setting that I can limit power to home in the general settings, and I can limit how much overall power is pulled from the grid. So for example, if the home is using 10 kilowatts, but I've got limited power set to the home at 5 kilowatts, then the excess power would be supplied by the batteries, right, if solar is not available. And so we can use this setting to limit how much overall power comes to the home. This is often useful if you have peak demand charges, right? If you go over a certain threshold. And so you can use this to limit that threshold. So also have limited power to the load, which, for a Sol-Ark 15K, often that's essentially the same thing. But with a 8K and a 12K, remember, you're only having a backed up loads panel. And so it's a little bit different wiring. So there are different features for an 8 and a 12K. But to get to the question, if we enable time of use here and you click the setup, it allows you to choose what days of the week or even set up seasons for time of use. And what we're going to do with time of use is control the use of energy stored in the battery. So if this setting here, if we enable charge, that allows the battery to charge when it's below the threshold of 70% state of charge. If we click the sell box here, it allows the battery to sell excess power to the grid. So for that customer that called in earlier, he wants to buy electricity at nighttime. So he would enable this and set up these different times. So what this does is it allows the battery to charge from the grid between the hours of 1 a.m. and 5 a.m. whenever the battery is less than 70% state of charge. And it will charge that battery up to 70% state of charge from the grid at 7,000 watts until it hits a 70% state of charge. So you can absolutely do that. You can customize those settings to when your electricity is the cheapest. You can buy electricity at that time, and then you can consume that electricity at the times that you want. So you can also set up here a sell option. So if you wanted to sell excess power to the grid, you could control output of the batteries between the hours of 5 p.m. and 9 p.m. And as long as the batteries are above a 50% state of charge, we'll discharge them at 2,000 watts back to the grid.
We have a question, Nathan.
Yes.
The grid cell, what value is that 6,000 there? Is that in amps, watts?
Oh, yeah, good question. Yeah, so that should be in units of watts. So that's 6,000 watts going back to the grid. Yes, 6,000 amps would be a very large value.
Mm.
So yes, good question. And there are entire talks on programming time of use. So Sol-Ark has a nice training on programming the time of use, and that's something that we can get into more. But you absolutely have the ability to tell the inverter when to charge the battery, and you'll
Yeah,
want to
and
set that for.
yeah, you asked me earlier what I like about Sol-Ark, Nathan, and one of the things I do like about Sol-Ark is that it's more advanced controller for time of use, different days, different
Seasons,
seasons.
yes. Yeah, you can do a lot with that time of use. A couple of just quick things here that I just wanted to include for completeness, which are kind of nice. For instance, if you want to factory reset your system, go into the basic setup and then factory reset tab. Check this box, click OK. It'll ask you for a password. Well, I'm giving you that password on the screen here. It's 9999, right? If you want to lock out changes, so you're doing an installation, you're doing all the setup, you want to make sure the homeowner doesn't mess with the settings that you put in there. You can go in and you can check the box for lockout all changes, click OK. It'll ask you for a password. You type that 7777, it'll lock the screen. Until you uncheck the box, the changes will not be able to be made on the settings. In the last couple minutes here, Daniel, and we will take time for more questions, but just want to highlight some of the great features of this battery. So we've got about 1,600 of these batteries in the field now. We've released a little less than a year ago, and just are having great success with this battery. It's been a great performer. Customers are happy, installers are happy because it goes in easily, quickly. I've installed a bunch of them. You've installed a bunch of them. We really enjoy this battery. Some nice features of the battery. Overall, you can put a total of 18 batteries together in a bigger system. So if you have a really large system, 120 kilowatt hour system, keep in mind you're only allowed to install up to 80 kilowatt hours in a garage. But if you have a detached building, or if you have the ability to do this, you could do some outside, some inside, etc. Then you could do a really large system like that. But do follow the code. And then for a single stack of batteries for smaller systems, we can do 6.6 kilowatts out of a single battery. Can do 10.5 kilowatts out of a 2-stack, and out of a 3-stack, we can do 14 kilowatts of continuous power. Briggs & Stratton has that lineup of batteries that I mentioned earlier, the PHI, the SimpliPHI battery. That SimpliPHI battery comes with a 15-year unlimited cycle warranty. No throughput limitations like some of the competitors, right? There's a full 15-year warranty there. A full 10-year warranty, unlimited number of cycles, no throughput limit, again, on that 6.6 battery. And that battery, you're guaranteed still 70% state of charge at the end of life, right after 10 years or at the end of warranty. And so really long-lasting batteries here. This is a picture of one of our high voltage systems. So these systems have those cell monitors that you can see on the front. If you're interested in high voltage, reach out to Daniel and I will put you in touch with our high voltage team. Showing a couple of nice installation examples here on the left side. You can see an installation there where we've got two stacks mounted up on the wall off the floor. It's a nice feature of this battery. We have wall mount certification for this battery. We can go into earthquake zone 4s with this battery. So really nice options for it. It's also quite easy to install. So I'm in the center there with some installers in my area. Putting that second battery module on. You can see we've put it pretty high up on the wall. And Daniel, I think code, if you're above, is it 30 inches or 36? You don't need any parking ballards in a garage.
It depends upon the height of the garage door. And this one, I believe it's 36. And Nathan, I'm ready for spring. I remember this day was hot day in that garage, right?
Yeah, I think this install occurred. I think it was 108, so I was trying to film it. My phone actually overheated. But I have on the screen here, Daniel, some weights of some of the competitors' batteries.
Hmm.
I mentioned these battery modules are 130 pounds, pretty easy for two guys to lift up and set into place. But looking at a Franklin at 400 pounds, a Tesla Powerwall 3 at 300 pounds, I mean, you can do this battery. Even the small Enphase 5 kilowatt hour batteries are 174 pounds. You can do our battery without the use of a lift. It goes for a really quick install. You can see that rack goes up first on the wall, then you stack those batteries there and attach them to that rack. So showing some examples here, Daniel, this one in the bottom left-hand corner, they've put a generator input for a portable there. That's a
Yep.
nice option. Do like how they've painted that conduit in the middle option as well.
Yeah.
Um, yeah, so some great looking installs there. Putting this slide in here for completeness. By the way, we are going to be sending this slide deck out to all of you. If you're interested in some of the native three-phase inverters from Sol-Ark, they're 30K, they're 60K. They pair with our high voltage batteries. Let us know if you're interested in doing some commercial units like that. We can, of course, get three-phase power out of the low voltage inverters as well. So I'm showing on the right-hand side, there's 7 Sol-Ark 15Ks there. And then on the left side, it looks like 7 or 8 Sol-Ark 12Ks there in parallel. And the one on the left I know is providing power for a village. The one on the right I think is in Connecticut. That's a nice install. And those are notably using our Phi batteries, which are fairly easily paralleled with these big bus bars. And so some great examples of large systems there. Daniel, you mentioned about some of the nice features of Energy Track being able to do individual module level monitoring. So if you click on any one of those batteries, you can get a lot of information back about the temperatures in the cell, etc. And you can do that remotely, right? You can check on your battery from anywhere. In
Hmm.
no amount of time, Sol-Ark has a nice monitoring platform as well, which brings in our battery information. It also gives us visibility to systems. So if you're having problems and you want to call us and get some support, we can talk you through things. We can look at your battery setup right directly through their app, and that's pretty easy to do. You get remote level monitoring from them as well. It automatically will recognize generator, AC coupled solar microinverters will show up in your screen. You get the ability to monitor how your system performs. You can get all this battery information as well. It's not quite as granulated as what you can see in Energy Track, but the nice feature of it is that you get that full system level, battery system level information, aggregated data here. And that's normally all that the customer wants, right? They want to know the state of charge of their batteries, maybe how much runtime overall they're going to have. Daniel, what am I showing?
We have an installer program. It's called the IQ installer program. Anybody that's an installer on this call, please go ahead and scan this QR code. It'll sign you up to be part of the program. We do require that you've done one install of our battery before you enter the program. But to get you that first install, we're going to offer you $1,000 off. So you get $1,000 off your first 6.6 install. Once you've done that, happy to have you be part of the program. We'll give you rebates, $100 per battery going forward. We'll put you on the map. We can also do some cross promotion for social media as well. And we'll send you a nice little gift bag as well.
Thank you, Daniel. So thank you for staying through to the end. Our email address is up on the screen, energystoragetraining@basco.com. That's Briggs and Stratton Company.com. Energystoragetraining@basco.com. Please send us an email if you're looking for those NABCEP credits. Let us know how your name should appear on your certificate. If it's just the same name as in your email, just email as short as subject certificate. We'll get it
Yep.
issued for you. But if you have a customized name that you should appear on your certificate, please do let us know that. And if you have any questions, please feel free to reach out to us and our team. We can put you in touch with our application engineers if you have questions about designing a system. Please do reach out. Daniel, I'm willing to stay an extra couple of minutes here in case there are any questions I need to answer.
Yeah, we do have a couple. So with regard to the smart load off the gen port, and this is the original question, if feeding a single EV charger off of the gen port directly wired Do you know if you need an overcurrent protection device between the gen port and the EV charger device? Or is the overcurrent protection device or current managed internally in the Sol-Ark 15K?
So I'm not certain of this, but I do think, I mean, the Sol-Ark does have PCS certification. And you can limit, there is a 100 amp fuse in the Sol-Ark on that 80 amp continuous port. So I would say that as long as your charger is drawing less than that, and most chargers are going to be drawing, I think 40 amps is a class 2 charger. It probably does depend on your charger. But I don't know that I would wire it directly. I'd probably wire a sub panel. But if you did wire it directly, I would think that the Sol-Ark PCS control settings should be sufficient to limit power on that. But I don't know so for sure, so I would like you to reach out to Sol-Ark with that question and verify. Next question, Daniel.
You know, John's asking, do you have an outdoor battery storage solution?
Well, the 6.6 battery can be installed outside, and if you're in a very cold climate where 14 degrees Fahrenheit is too high of a temperature for you, you need to charge when you're below zero. Then we do have a heated battery enclosure option for the SimpliPHI batteries and the PHI batteries. So that's essentially we have heaters integrated into the BMS with temperature sensors that'll turn on when those batteries are cold. It's a little bit less efficient because you are using the batteries to keep the batteries warm. But those heaters are on a thermostatically controlled switch to allow them to heat the batteries only when needed. So yes,
Yeah,
we do have
exactly.
options.
Yeah, and somebody had mentioned that in the Q&A about cold weather considerations as well.
Yes.
There was one question. It was way back on the AC coupled slide, so I'm going to try and ask this. And maybe we might have to go back. He says, is that a mutually exclusive checkbox, right? Use gen or for AC?
Yes. So if we use the generator port as an AC output, then it's only as a AC output, right? We can't bring the generator in if we're using it as a load output, as a smart load output. Yeah, so good question. Yeah, we don't want to bring power in there from that port if we've checked it to use it as an AC output.
That's all the questions. Again, email energystoragetraining@basco.com for those NABCEP certificates. We'll go ahead and email out this entire slide deck and the recording so everybody has this for reference. Nathan, any final thoughts on programming for a Sol-Ark?
Well, if you have questions and you're interested in learning more, we do have an advanced generator programming talk coming up with Sol-Ark. So if you have questions about that, let us know. Do look at our other trainings that we have coming up. Daniel and I are continuously trying to create content to help the installers out there. We also want to thank you for your time. We know it's valuable. We know you're probably not making money on billable hours right now. So thanks for taking the time with us. We hope we've taught you something today. And if you have continuous questions, our contact information is on the screen. Thank you, everyone.
Thank you.